In this video, we're going to talk about operations involving functions. Okay, so these are operations that we normally use for real numbers: addition, subtraction, multiplication, and division. Okay, we can also perform those operations for functions. Okay, so for example, we have here the sum rule. Basically, we add two or more functions, and we commonly denote or represent sum of two functions in this manner. Okay, so we have here f and g. These are two different functions and they are defined in terms of the input value x. Okay, this does not mean that we take the sum of f and g and then multiply by x. No, this is just a notation, right? F and g are functions in terms of x. All right, so f plus g of x, this means that we take the sum of f of x and g of x. All right, then the difference rule, basically subtraction operation, right? So we take the difference or subtract g of x from f of x. So this is how we represent this operation if it involves functions. Okay, and this means take the difference between f of x and g of x, basically subtract g of x from f of x. Okay, and then we have here product rule. So product between two or more functions. So this is how we usually represent this operation if functions are involved. Okay, so f times g of x, basically it means f of x times g of x, right? Now lastly, we have the quotient rule. So basically you take the quotient of two or ratio of two functions. Again, this means we take the quotient, so f of x divided by g of x, and g of x must not be equal to 0, because if g of x or the value of g of x is 0, then we have an undefined value overall. So we do not want that to happen. So the denominator must not be equal to 0, right? That's the condition. So let's work on some examples. We have here given if f of x is equal to x minus 5, and if g of x is equal to x squared minus 1, then we are asked to find letter A. We have here the sum of f and g. Letter B, the difference. So in this case, we subtract f from g. Okay, and then letter C, lastly, product of f and g. Okay, so let's start with letter A. Here we have sum of f and g of x. Remember, this is equivalent to f of x plus g of x, right? And so we plug in the equivalent expressions for f of x and g of x, right? F of x is x minus 5, so we plug in x minus 5, and then plus g of x, where g of x is what? This one, x squared minus 1. Okay, and so what we can do next is to simplify. But to simplify, we can start by combining like terms, and then we rearrange. Okay, so in this case, we have 4 terms, and we only have one quadratic term, this one. So let's write this first. So we have x squared, right? And then we also have one linear term, x. So let's write plus x. And then we have two constant terms. So minus 5 and minus 1. So negative 5 plus negative 1, that would be negative 6 or minus 6. Okay. And then lastly, it's preferable that we express our final answer as, or it's preferable if we express our final answer in factored form. Okay, so we factor, we check if this is factorable, and then we express it in its factored form. Okay, so this is a quadratic expression. So to factor a complete quadratic expression, and if the leading coefficient is 1, then we can simply look at the constant term, right? It's negative 6. And let's look for factors of negative 6 whose sum is positive 1, the coefficient of the second term or the linear term. Okay, so negative 6, factors of negative 6 that will result to a sum of positive 1 in this case. So that would be positive 3 and negative 2, right? So we say, so again, factors of negative 6 resulting to a sum of positive 1. So that's positive 3 and negative 2, right? So we can check by taking the product. So positive 3 times negative 2, that would be negative 6, right? And then if we take the sum, positive 3 plus negative 2, that's positive 1. Okay, so we say x plus 3 times x minus 2. This is now the final answer. Okay. Next, letter B. So for letter B, we take the difference g minus f of x, which is equivalent to g of x minus f of x, right? And then we plug in the equivalent expressions. So we have here g of x is what? X squared minus 1. So plug in x squared minus 1. And then minus f of x is what? F of x is x minus 5. So plug in x minus 5. So we now have what? X squared minus 1, and then we distribute negative 1. So that's minus x. And then negative times negative, that's plus 5. Okay. Then again, we collect and combine like terms and then check if it's factorable. Okay. So we have here x squared, the only quadratic term. So let's just copy x squared. And then minus x. This is the only linear term in this case. So just copy minus x. And then we have two constant terms. Okay. So negative 1 plus 5. Or that's 5 minus 1. So that's positive or plus 4. All right. And then we also arrived at a complete quadratic expression, right, with a leading coefficient of 1. So we'll look at the last term, the constant term, and check if it has factors that will result to a sum of negative 1. Okay, so in this case, we have factors of 4. It can be 2 and 2, right? However, we want the sum to be negative 1. So 2 and 2 will not get a sum of negative 1, or 4 and 1. However, we still won't get a sum of negative 1. So we say this is the final answer, okay? Since this is not factorable in this case. Okay, next. So letter C, product of f and g. So f times g of x equivalent to what? F of x times g of x. So we'll just take the product of the two functions, okay? So we have here what? Let me rearrange the solution. All right, so let me write the second line here. Again, this is equivalent to f of x times g of x, right? And f of x is x minus 5. So we copy x minus 5. And then we multiply this by g of x, where g of x is x squared minus 1. Okay? And then, again, we want the final answer to be in factored form, right? So there's no need to distribute or expand. So we can just simply say this is the final answer, or we can factor further, right? So x minus 5 And then we can factor further x squared minus 1. X squared minus 1 is difference of two squares. So this is factorable by x plus 1 and x minus 1, right? So again, we want our final answer to be in factored form, okay? Because later on, if we encounter complex expressions or complex functions, it would be more convenient if we simplify by factoring, so we can clearly see the common factors and we can cancel out common factors or combine common factors, so on and so forth. Okay, that's why we want everything to be in factored form. Okay, next, let's have if h of x equals x squared plus 6x plus 9 and j of x equals 1 over x plus 3. So we are asked to find letter A, product of h and j, so h times j of x. And then letter B, we are asked to find the quotient of h and j. Okay, so let's start with letter A. So A, we are asked to find h times j of x. Okay, remember this is equal to what? H of x times j of x. Okay, and then we'll plug in the equivalent expressions for h of x and j of x, right? So h of x is what? H of x is x squared plus 6x plus 9, right? And j of x is what? 1 divided by x plus 3. Okay, and then again, we express everything in terms of their factored, or in terms of their factors, right? So x squared plus 6x plus 9, this is a perfect square trinomial, right? So this is equivalent to what? X plus 3 squared, right? 3 times 3 is 9, and then 3 plus 3 is 6, right? So it's a perfect square trinomial. And then j of x again is 1 over x plus 3. So we can cancel out x plus 3, a single x plus 3. Okay, so we say cancel out x plus 3 and 1 factor of x plus 3 here. So we are left with what? 1 factor of x plus 3. Okay, so final answer. Next, letter B, we are asked to find the quotient of h and j. So h divided by j of x, all right? And this is equivalent to h of x divided by j of x, okay? Where h of x is, again, it's x squared plus 6x plus 9. And then j of x is 1 divided by x plus 3. So we have a fraction in the denominator. Remember, we can convert division operation to multiplication, right? By expressing the denominator or the divisor as a reciprocal. Okay, so we say again x squared plus 6x plus 9 is x plus 3 squared, right? We've established this earlier. And then instead of dividing this by 1 over x plus 3, we say multiply this by reciprocal of 1 over x plus 3. So reciprocal is x plus 3. So we multiply this by x plus 3. Okay? And then since we have factors with the same base, x plus 3 and x plus 3, so what do? we combine them by taking the sum of the exponents. So 2 plus 1, that's 3. So we say x plus 3 cubed is the final answer. Next, we have here f of x equals x cubed minus 11, and then g of x is equal to 2x cubed minus 3. Then lastly, we have h of x equals x plus 2. And then we are asked to find, so we have g minus f all over h of x. All right. So let's start. We have here g minus f all over h of x, right? And then we write its equivalent in terms of the functions. So g of x, and then from g of x we subtract f of x, right? All over h of x. Okay, and then we just plug in the equivalent expressions. So g of x here is 2x cubed minus 3, right? So we plug in 2x cubed minus 3 minus f of x. F of x is x cubed minus 11. And then this is all over h of x. H of x is x plus 2. So we just plug in x plus 2. Okay? And then we simplify. First, let's copy 2x cubed minus 3. So first we distribute negative 1. So we say negative x cubed. Negative times negative, that's positive. So plus 11. And then x plus 2 on the denominator. Okay. And then next we simplify, collect and combine like terms. So if we focus on the numerator, we have here 2 cubic terms. So we have 2x cubed and negative x cubed. All right, so we combine them. So we have here 2x cubed minus x cubed. So that's x cubed, right? And then we have 2 constant terms, negative 3 and positive 11. So we say negative 3 plus 11, that's positive 8. So plus 8, all right? This is all over x plus 2. Okay? Then let me transfer the solution here. So again, we have, let me rewrite g minus f over h of x. And then we have here, from the last line, we have here x cubed plus 8 divided by x plus 2. Okay. And then we simplify by expressing, in this case, we have x cubed plus 8. We express this in its factored form. Okay. X cubed plus 8, this is sum of 2 cubes. Okay. So we can factor this one. This is actually equivalent to what? So if you can still recall special products, factoring from special products, this is actually factorable, right? So we have, again, we have a sum of 2 cubes. 8 is 2 cubed, right? So we have sum of 2 cubes, x cubed plus 2 cubed, and this is equivalent to x plus 2, all right, times, so we have here x squared minus 2x plus 4. Again, this is taken from special products of, so we have here, let's say, a cubed plus minus b cubed. Okay, this is for sum and difference of two cubes. Okay, so if it's a sum, then we say this is equivalent to a plus b. If it's a difference, then we also say a minus b. Okay, so we just follow whatever operation is given in the problem. If it says addition, then we also say addition in its equivalent binomial. Okay, if it's subtraction, then subtraction also. All right, and then we multiply this by a trinomial in the form a squared, and then here we interchange the operations. So if it's originally addition, right? So addition in the given, addition in its binomial, we say here this should be subtraction. Okay, so addition, addition, subtraction. And then if subtraction in the binomial, addition in the trinomial. Okay, so next we have here the product of a and b. Okay, and then lastly we add the square of the last term, b squared. All right, so in this case we have x cubed plus 8. So in this case a is x, right? A is x, and then b is 2. Okay, because 8 is 2 cubed, right? So in this case we have addition, so we follow the order of operations, plus and then minus. All right, so let's isolate x cubed plus 8. So we have here x cubed plus 2 cubed, right? So we follow the special product. So a in this case is x, so we plug in x. Since it's addition originally, then we also copy addition. All right, and then in this case b is 2, right? So b, in this case b is 2, so copy 2. All right, and then for the trinomial portion, a squared, so that's x squared in this case. And then again, since it's originally addition, then on the trinomial we perform subtraction here. Okay, so minus, and then product of a and b, a is x, b is 2, so that's 2x. And then we add the square of b. B in this case is 2, so 2 squared is 4. Okay, so this is why we have x plus 2, this one, x plus 2 multiplied by x squared minus 2x plus 4. All right, and then this is all over x plus 2. Okay, so as you can see, we can factor out, we can cancel out x plus 2. So we are left with x squared minus 2x plus 4, and this is not factorable in this case. So we say this is the final answer. Okay. Next, we have here 4 functions. If f of x is equal to 2x squared minus 8x plus 3, if g of x is equal to x squared minus 3x minus 3, and then we have here h of x equals 3x squared minus 2x minus 5, and lastly j of x equals 4x squared minus 9x plus 5, right? And then we are asked to find g minus f all over h minus j of x. All right, so let's start. Copy the given we have here, or copy the required in this case. So g minus f all over h minus j of x. Okay, so this is equivalent to j of x And then from j of x, we subtract f of x divided by h of x minus j of x. Okay. And then we simply plug in the equivalent expressions for all of the functions. Okay. So g of x, this one. So plug in x squared minus 3x minus 3. And then subtract f of x. So f of x is 2x squared minus 8x plus 3. Alright. And then let's proceed to the denominator. H of x is 3x squared minus 2x minus 5. And then we subtract j of x. J of x is 4x squared minus 9x plus 5. Okay. And then let's distribute first -1 for g of x and j of x. So we just copy x squared minus 3x minus 3, and then again we distribute -1, so this is minus 2x squared, right? And then negative, negative, so positive or plus 8x in this case, right? And then negative, positive, so -3 or minus 3. Okay. And then on the denominator, we have 3x squared minus 2x minus 5. And then distribute -1, so this gives us -4x squared. Negative, negative, so positive 9x or plus 9x. And then negative, positive, so that's -5 or minus 5. Okay. And then next, we collect and combine like terms, right? So let me just rewrite g minus f all over h minus j of x. Okay. And then from this line, we collect and combine like terms. So let's focus first on the numerator. We have two quadratic terms, x squared and negative 2x squared. So we combine them, x squared minus 2x squared, so that's minus or negative x squared, right? And then the linear terms, we have negative 3x or minus 3x and positive 8x. So that would be negative 3x plus 8x. So that's plus 5x. Okay, and then lastly, for the constant terms, we have negative 3 minus 3, so that's minus 6, right? And then on the denominator, we also have two quadratic terms. So 3x squared minus 4x squared, that's negative x squared. Okay. And then two linear terms also. So negative 2x and positive 9x. So negative 2x plus 9x. That's positive 7x or plus 7x, right? And then negative 5 minus 5, so that's minus 10. Okay. And then we simplify by factoring and canceling out common factors. In this case, the leading terms are negative, so it would be more convenient if we convert them to positive by, how do we do that? We factor out -1 and we cancel out -1, right? So factor out -1 so as to convert our leading term to positive, okay? So that later on it would be more convenient if we factor them. All right. So negative x squared, after factoring out -1, it becomes positive x squared. Okay. And then positive 5x becomes negative 5x, right? And then negative 6x becomes positive. I mean, negative 6 becomes positive 6. Okay? Then we do the same thing on the denominator, factor out negative 1. So this gives us positive x squared, negative 7x, and positive or plus 10, right? So we can now cancel out negative 1. So we are left with x squared minus 7x plus, negative x squared minus 7. That should be 5. So negative x squared, focus on the numerator. So negative x squared, positive x squared minus 5x plus 6. Okay. And then on the denominator, we have x squared minus 7x plus 10. All right. So we can factor out x squared minus 5x plus 6. This is actually equivalent to x minus 3 multiplied by x minus 2. Okay. So you can check by taking the product of negative 3 and negative 2. So that would be negative 3 times negative 2. So that's positive 6, right? And then you take the sum, negative 3 plus negative 2. So that's negative 5. Okay. Then on the denominator, we have x minus 5 times x minus 2. Okay. Then again, we can check by taking the product first. So we have here negative 5 times negative 2. So that's positive 10, right? And then take the sum. So that's negative 5 plus negative 2. So that's negative 7. Okay. Therefore, it's correct. And then, as you can see, x minus 2 is common for both the numerator and denominator. So we can cancel x minus 2. And so we are left with x minus 3 divided by x minus 5. Okay, so we say, let me write the final answer here. So we say g minus f over h minus j of x is equal to, in this case, ratio of x minus 3 and x minus 5.